All right, gang, hello. Was asked actually the other day, what is your setup for Planetary? You know, it's a group that I belong to, and I post a number of Planetary and Lunar pictures there. And it kind of, one of my recent posts sparked that question, and I've gotten it before, and I've been wanting to put together a video. Just, you know, doing these videos actually takes time, and you got to edit them, and you got to post them, and so it's a little time consuming, but I thought I'd go ahead and knock it out. So obviously I've got the 16-inch Dobsonian scope. It's a G model, meaning it's a go-to. It can slew, it can track in whatever tracking rates it's set to, lunar, solar, or sidereal. And what I'm going to show you today with regards to the setup is applicable to any size scope. You could have an 8-inch, 14, a 10, it really doesn't matter. And it doesn't necessarily have to be a go-to scope to use some of what I've got here in terms of setup. And it's like everything else we do in this hobby. You know, I could watch a great video of someone's setup with the equipment they have, and not everything they have or what they have in the video is applicable to me, but I can choose and pick small parts to take what they have in terms of setup and then use it for mine. So that's the intent here. So obviously I'm going to keep the dust cover on to protect the optics. I've got a hole I've had to cut here to make room for the bobs knobs. And so let's get started. One of the first things you'll notice here in my setup is that I've got some welder's weights here. And I don't know, these are a pound or so, but I keep them, they're magnetic, and I keep them on the front of the scope almost all the time. I want the scope to be predominantly nose heavy all the time. So no matter what I do, camera-wise, eyepiece-wise, taking stuff out, putting stuff in, I want there to always be a downward force, an overall net force down against the clutch, so that suppose I have a heavy eyepiece here and I've just perfectly centered Saturn. Now I'm ready to take the eyepiece out, put my Planetary camera in. Well, when I take the eyepiece out, I don't want the nose of this thing moving up or even jittering up a little bit. And some of these scopes, the clutches aren't perfectly tight. There's always a little bit of play, and no matter how good or how tight your clutch is, there's always a little bit of play, and we call that backlash. So I want there always to be a net force in this direction, so that no matter what I'm doing configuration wise here, it'll always stay nose heavy. Now there are a few exceptions to that, not necessarily during Planetary, but if I'm doing DSO here, as I'm tracking up, you know, I'm in the northern hemisphere, so my targets track up, they reach the apex, and then they track down. So as I'm tracking up, I want nose heavy, nose heavy, nose heavy, and then when I get to the apex, then I would probably want tail heavy, tail heavy, tail heavy. For backlash purposes, I'm wanting the scope to always be against the driving warm gear. So I want the driven gear attached to the body of the scope to be pressed against the driving warm gear in my setup, in the mechanics parts here. So I always have weights up here, and again, different scenarios don't require them, but generally speaking for Planetary, I always have them there. So that's that. So I've got the ASI 290 here. There's also the 224, which is compatible, or not compatible, it's comparable to this. I don't own the 224, but just looking at the specs, I believe the 290 actually can give you a little faster frame rate. Price-wise, I think the 290 may be a little bit more expensive, but every now and then you can find them on sale, which is what I did with this one. I can get upwards of 300, 350 frames per second, depending upon the frame size I have set. These are all things we'll talk about when we do the capture instructional video. But I can get, you know, on a dim Saturn, we're seeing conditions are questionable. Maybe a little bit of smoke haze from all these crazy wildfires. I've got to set the exposure time a little longer. I can still get, you know, 100 frames per second. Jupiter a little bit brighter, I can get 250. Mars, when it was at opposition last year, I was looking at 360, almost 400 frames per second. And it's a great camera. It's USB 3, and we're going to talk about USB 3 versus 2. And so I've got that set up there. You may have noticed I got the AEF focuser here. It's an electronic automatic focuser. I don't use the automatic feature of it. I did buy the hand controller, which I have dangling down here, and sometimes it just dangles down here, and sometimes I put it on my little workbench here that I'm going to show you in a second. The other thing, I am not a fan of tension being on cables and cords. So you'll see where I've taken the AEF remote control cable that's plugged in here, and I've actually gone around the focuser body, and then it's hanging down. So if anything gets snagged on this, it's not pulling on the connection on the back of the focuser. Okay. With that being said, the focuser cable is not a high data rate cable. It's just provides 5 volts power and a little bit of data to and from the focuser. So it doesn't need to be 3.0, it'll be 2.0. The camera, however, your Planetary camera, it's got to be 3.0. We are pumping lots of data from the camera to our laptop or computer or whatever it is you're using. So we've got to have 3.0. Now with that being said, I'm going to stand back here and talk about 2.0, 3.0 compatibility. 3.0 is reverse compatible to 2.0. In other words, if you got a 2.0 device, most 3.0, in fact, I don't know of any that aren't, 3.0 hubs, 3.0 cables, etc., as long as the connector fits, is going to work fine with 2.0. Obviously, it doesn't work the other way. So when you're buying USB hubs, or if you need a USB cable, just buy 3.0 as long as the connector fits your 2.0 device. There may be some rare exceptions out there, but so be it. So why do I bring that up? Because what you don't want to do is pack all this stuff up into a plastic bin, break down your scope, drive, 3 hours to a dark sky site and realize all you brought, you failed to bring your 3.0 cable, but guess what? You got the extra 2.0 cable there doing nothing in the bottom of your plastic tub, and guess what? It ain't going to work with your camera. So just if you're going to buy cables and extra cables, etc., or a powered USB hub, just get USB 3 cabling to include, which I'll point out here in a second. I've got a long USB 3 extension cable, and it's USB 3, even though I may be driving USB 2 devices in it. All right, so let's go over here to the back side. So again, I've got my focuser cable, and I got to label everything because I'm an idiot. So focuser, I think this one's labeled cable down here in the end. But notice I've got this little knob. When I disassemble this scope, I'll undo this knob, and that allows me to pop this lower OTA off of the mount, and it just stays on there tight. But notice I have my cables that come down, and they just do one turn around this, then they go down to my USB hub. And the reason why is, again, if I trip over any of this cabling, or it gets snagged on something down here, I'm putting tension on this knob and not the device itself up here. I'm very paranoid about devices getting yanked out of the focuser onto the ground and all that. So let's take a look down here. I've got a USB 3, so it's high speed, powered hub. Now I don't have the power part plugged in right now, and usually I don't need it. The voltage provided by the USB 3 cable coming out of the laptop is enough to drive pretty much all my devices here when I'm doing Planetary with this telescope. And in fact, this USB 3 extension, it's not just an extension cable. It's got this, I'm going to just zoom in, just buy this thing if you need it. I don't know what active extender means. Maybe I could have looked it up before doing this video, but you can tell it's not just the normal plug at the end of the cable. And so there may be a power booster, some power booster circuitry in here for that. But I haven't had to, I do use the power part of this, and it's an adapter that plugs in here. I have used it before, but many times I do not. What's cool is I can turn the devices on and off, and here we go. So I've got my focuser in one, camera in the other, and what's this third device plugged in here? Oh, yeah, we'll talk about this in a little bit. But this third device is my USB to serial cable, which I've got kind of wadded up, stuffed under here. Okay, but I keep this all kind of down in here, so as the scope turns, I don't have cabling dragging across on the ground. Okay, so my power jack that goes into the mount is like what you guys seen before, no surprises. But what I do want to highlight, and of course I just use the 12-volt adapter and I can plug it into extension cord. What I want to highlight is this. I've set up before and had some really great Planetary, perfect seeing, capture rates are fine, the scope is doing wonderful. There's some nights that scopes don't track well, and there's some nights they're just, you can go in, sleep for 3 hours, come out, and the scope still has the target dead center, and then you discover your laptop battery is dying. So what do you plug it into? Well, you can't unplug the scope, right, from the power source. So I always use one of these things. I even bring these things to the field with me when I use my 12-volt to 120-volt converter. So that way, and my extension cord plugs into the house here. So I've always got options for other power sources here. Whether it's laptop or whatever, you can make up whatever you want to. But always be sure to put one of these on the end of your extension cord, so you've got options for power later, and you don't have to turn off your scope or anything of that nature. So let's come over here. This is the hand controller, just like you guys have, and the hand controller has a little I don't know what you call this thing, a little expandable cord, you know, the curly Q or whatever. I took mine and I unplugged it from the hand controller and I unplugged it from the mount and I stretched it out. I put it between my two hands and went full shoulder width apart to stretch this thing out because I want to occasionally be able to come over here. I put Velcro on the back of the hand controller, and every now and then I want to put the hand controller right there. So I can, in a sense, kind of remotely slew my telescope to stay on the target while I'm watching my laptop. Every now and then, I'm not going to turn this laptop much because I got cables plugged in the side. I don't want to snag a cable and mess up the USB jack on the side of the computer. But every now and then, I'll have my computer oriented this way. And so as the target, look at that reflection, you don't like that, you don't want to see that. As my target, the planet's drifting a little bit, I can make small corrections via the hand controller right here without walking over to the scope and then having to turn the laptop to see what my inputs are doing. And to make that happen without putting too much tension on the hand controller, I stretch this bad Johnny out here. Because I actually do more, my opinion, I do more scope slewing away from the scope than I do necessarily standing right next to it. So let's talk about what's plugged into the hand controller here. This is the the USB to serial conversion, and it's a normal cable. Let me grab it here. It's a USB cable, but it terminates with, this isn't RS-232, but terminates with a serial port. And then I have a serial cable that connects to that terminates with the RJ32 or RJ14. Again, I'm not too bright. I don't have all these numbers memorized, but basically the phone jack, and it's one that would fit into the hand controller here on the bottom. By the way, notice I can talk about not only do I have Velcro here, but I have Velcro on here too as well. And this thing lives up here 90% of its life. I found, even though as straightforward as this may seem, at night when I reach down to grab this and pull it out, these cables get hung up and caught up on here, and it jerks the hand controller out of my hand, and I've dropped it way too many times. So while I'm using the telescope, that thing actually lives up there. So I have the serial cable plugged into the hand controller. And what that does, this allows me now to control the scope through my laptop, and I can do that through an ASCOM, however you want to pronounce it, ASCOM controller, and again in my capture video I'll show you how to do that. Or I can control it via Stellarium. Like if I'm hunting and pecking for some DSOs to image, I can just control the telescope via Stellarium. But what's really nice is even during Planetary, through the ASCOM controller, ASCOM, again, whatever you want to say, I can actually leave the hand controller there, and through my laptop with a little bitty miniature hand controller that pops up with the ASCOM hub. Let me turn this thing. You guys don't need to see my ugly mug shot. So with the ASCOM controller here, I can actually use the mouse to just make slight adjustments to the telescope to keep the target centered in the crosshairs during imaging Planetary. Now let's talk about this. The field of view of a scope this size, coupled with the small chip size of a Planetary, means the actual field of view of this setup is very narrow. So rarely, I don't know if it's a function of an alt-az mount or whatever. In fact, I have a gem mount with an 8-inch astrograph on it, and the same thing holds true. Rarely does this scope, or my other one, slew directly to the planet. Okay, and you guys know that. So I will use the finder scope and it's got crosshairs, to put the planet directly under the crosshairs, and then I will look in my camera via laptop and make sure that it's centered in my software, like SharpCap Pro, for example. If it's not, then I'll center it in SharpCap Pro under the crosshairs, come here and make any kind of fine adjustments I need to my finder scope. As little, I never touch this thing, but for some reason, I don't know if it's temperature changes or what, sometimes I find that my finder scope is slightly out of alignment. Now let's talk about another quick subject. Again, given the narrow field of view of the telescope itself coupled with the small chip size, that means the actual field of view is very, very, very narrow, especially if you're using a Barlow. If you're using a 2x Barlow, you've cut the field size basically in half. So even with the target directly under the crosshairs, and I know the optics are perfectly aligned, that doesn't mean the planet may necessarily be in the center of the camera or even anywhere in the camera's field of view. And there's some tricks to putting that, to finding a planet that's somewhere in your field of view, but you're not quite sure where it's at. And I'm going to do that during the capture video. But I am going to show you this during daylight. So I'm going to unplug, first let me tighten this back up because I'm doing this one-handed. I'm going to unplug the Planetary camera, set the cable here, and I'm going to take this Planetary camera out, set that guy right here. I'm going to put in a low-powered eyepiece. Just one of these is fine. Again, I'm doing all this one hand, holding the camera with one hand and doing this lens swap thing with the other. I'm not even going to flip the eye relief rubber lip there. I'm just going to set this here. Take out this 2" to 1", 1 1/4. Put that guy in there just like so. So now I'll put in a low power eyepiece, and obviously this would be flipped up for eye relief. So I'm going to center the planet in my finder, and again this all assumes that my finder and scope are aligned. Look in here and find that, well, it was slightly off, so I'll center it now in the eyepiece. Center it now in the eyepiece. If I really want to get even more precise, and normally I don't have to, I've got an illuminated 1 1/4" eyepiece here, illuminated reticle with crosshairs in it that are illuminated in red. So I could put this in there and center it up even more. But I find that I'm fairly accurate enough to just center it in the field of view of this eyepiece. Now I take this eyepiece out, and by the way, this is why we have the counterweights here, because this heavy eyepiece, everything's balanced. When I take this out, I don't want the front of the scope to slew upwards now that it's lighter because I took this off. So we always keep the nose heavy. So now I put my eyepiece down, very conscientious of where my feet are at. I'm always looking down to make sure, and I wear one of those light things, you know, hiker lights or whatever you want to call it, that goes on your forehead that I can turn on and off. Oh, wrong screw, sorry. So that while I'm doing any of this, I really don't care about light pollution and all that. I'm not imaging. I don't have friends standing near me trying to do long exposure photography. So I turn that light on. I'm always looking down to make sure I'm not tripping over on any of these cables. So I got my Planetary camera back in. I'm going to tighten that, tighten that, tighten that, give it just a little pull, get my cable, put it back in. And now the target should be centered in the field of view of the camera. It doesn't necessarily mean it's in focus. Now I'll go to my capture software. I'll run the gain super high, run the exposure super high, so I get a white big blob in the middle of my screen. Then I center that blob in the middle of the crosshairs in SharpCat Pro, and then now I can grab the focuser here. And in fact, I think the focus is probably powered. Nope, I might have to cycle the hub on and off. But anyway, oh yeah, it is powered. In fact, you can see it turning there. We got a high speed, low speed, and sure enough. So now I just run the focuser while I'm looking at the laptop. And by the way, I bring this thing over here like so, and I anchor the cable under the corner of my laptop so that that is always there. Sometimes I stand right here, and I normally have this work table closer to the scope, but I have it pulled away a little bit today so I can walk in between there and do this video. But sometimes I have the focuser cable coming up over here, and I can actually with my right hand focus that thing, or left hand focus it and use the right hand with the mouse. And again, a lot of this we'll cover during the capture part. Once I'm imaging though, I don't change this thing, right? If this is anchored under here and I'm actively capturing, I don't want to take this focuser handle and then let it dangle down here, because even just the tension now coming into that cable pulling on this area up here was going to cause enough jitter to give me some bad frames here. Will the software throw it out? Of course, but why give yourself bad frames if you don't want it? So big picture, that's the setup. Let's talk about focusing. Obviously I can't grab this thing and just focus at will, right? I have to use the autofocuser. So, and by the way, while I'm doing my 2-star alignment, this thing's in the way. So I normally don't even have that near my telescope during alignment. I just have the telescope here. I have it powered on. I've got my covers off the eyepieces here. I don't even have the camera out of its case yet. What I put in here is a low-powered eyepiece. Okay? Now, for my 2-star alignment, I slew to the 1st star. I center it up in the in the finder scope, but then I put in my low power eyepiece, and guess what? It's probably going to be out of focus because the last focus setting I had here was for this Planetary camera. So do I take the hand controller and focus for the eyepiece? No, I just leave these screws loose and I slide the eyepiece in and out until my alignment star is in focus, and then I tighten it to lock that eyepiece in place. And of course I'll lock both screws. I do my alignment on my first star, then I set it up, then I tell it, yep, now slew to the second star, and I do my alignment there. For Planetary, eyeballing the alignment star in the center of your low power eyepiece is adequate enough. Let me repeat that. For your alignment process, whether you use brightest star or 2-star or 1-star alignment, putting the alignment star visually in the center of your low power eyepiece. Remember, I've just got the camera here I'm not taking it out. I could point at this if you want. Just putting the alignment star visually in the center of this eyepiece is adequate and enough alignment for your telescope. Now, there are some out there who say, well, then you're not going to get good tracking. No, that's not true. Tracking rates, how they're calculated, depends on your location and your elevation. Accurate slewing depends on accurate alignment, your position on the Earth's surface to include elevation, and time of day. All right? So as long as you put in your good latitude, longitude, and elevation, you're going to get good tracking rates. Right? Slewing has to do with alignment. And remember, we're going to slew to the planet, get it roughly where it's supposed to be, and then we're going to fine-tune it with our finder scope. Okay? The point of all that is I don't need to do anything with this focus. I don't need to grab the hand controller and mess with it while I'm doing my 2-star alignment. All right? Now, once my alignment is complete, I slew to Jupiter, for example. Then I take this wheeled workbench, whatever, that normally sits over here, and then I slide it over here. I double check all my cabling, pull everything in, get my laptop oriented the way I want it, get the hand controller over here or over here if I've got my laptop oriented this way. Then I fine tune the slew, and then I begin my imaging and go from there. What's cool about this focuser, and it holds true for most electronic focusers, is that it provides feedback to the controlling software. And so I have a shortcut on my desktop that I call up during imaging. And this thing can range from position 0 to like position 44,000. I don't remember exactly what the number is. But every configuration here, whether it's just the camera by itself or the camera with the 2x Barlow or the camera by itself with a UV IR cut filter, that changes focus a little bit. All of these different configurations, whether I've got a Barlow in there, IR cut filter, or any other kind of filters, changes the focus position. So while I'm imaging, when this stuff was kind of new, when I got what I thought was perfect, or at least the best focus possible, then I would make a note in that notepad document on what that focus or position was. So, for example, this configuration here for Jupiter with camera only, no IR UV cut filter, may be position 37,105. So no matter where this is, maybe I did DSOs the other day, or maybe I had a Barlow the other day and then just put it all away and went to bed. Well, I can come in here to the ASCOM software that controls the focuser and tell it go to position 37,105, hit enter, and this thing just starts motoring. And now I know I'm going to get pretty darn close to focus. Not perfect. Why? Because focus depends on many factors to include temperature, expansion, contraction of the OTA in the mirror, etc. But I know that 37,105 is going to be awfully darn close. So that's one of the advantages to an electronic focuser. The other advantage is this. Here I am with a small little representation, little image of Jupiter on my screen in SharpCap Pro. I haven't started capturing yet, but I am looking at a preview. Now it's time to really fine-tune the focus. So I come over here to my 11:1 ratio focuser knob, and I begin to just adjust it. Guess what's happening to Jupiter over here in the screen? Man, it's all over the place. It's jittering, it's up and down, left and right, especially if I have a Barlow. I can't tell if something's in focus, if the thing's jittering all over the place. So what I have to do is kind of guess, let go, come over here, let it settle down, and then go, well, say to myself, well, not quite there yet. So now I got to come over here and do it again. And there's just a lot of jitter and a lot of movement Whereas on the other hand, with this electronic focuser with the hand controller, by the way, you can buy this thing without the hand controller. I recommend get it. Just get the thing. I can now have the hand controller either in my hand or anchored underneath the corner of the laptop like we talked about. And now, without the telescope moving at all during focusing, I could sit here and look at my laptop and just make my adjustments here with slow and fast, etc. One of the things too, I'll talk about this focuser. I'm going to tell you when I press the fast button, and then look at the delay it takes to move. I'm pressing now. About a second delay. Pressing now. So when I'm focusing, I count to 1001. Then I know the focuser is moving. Because I could sit here and go click, 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 and then I tell myself it doesn't look like anything's changing, and I don't even know if it's focusing or not. So we call that backlash in your focuser, and that's what's happening there. It's even worse when you go to the slow method because it takes longer for the motor's turning slower, so it takes a little bit longer for it to take out backlash in the gear system. It's a planetary gear, little transmission thing, whatever, inside here. And that's what drives the rod that's pressed up against the flat part of the focuser tube, and that's what makes it go up and down. But under slow setting, which I have it set here, you'll see there's even a bigger delay. Pressing now. Boom, it just started moving. Pressing now. Boom, just started moving. So there's like a 2-second delay. So anytime I know I'm focusing one direction or another, I'll either count to 1 second or 2 seconds. So, ladies and gentlemen, that's the basic setup. I think I've covered everything in terms of Planetary. Again, we're not going to get into capture specifics because we'll do that in a separate video. I'll come out here, and I've been wanting to do it for a year or so, but just haven't had a chance. But that's the setup for Planetary. As always, why do we do this? Why do we share images? Why do we share videos? Why do we, communicate with one another in this great hobby? It's to learn and get better. So that's the purpose of this, and we should always be in the business of learning, right? So if you've got something that you do that's better than any of this, then please share so we can all learn. I obviously love answering questions, and if you got any comments, then please leave those below. And as always, if you liked any of this, click like, and I'd ask that you subscribe too as well. Happy hunting.